Jai Hind everyone. Now we will start at chapter number 4, Exploring Magnets. Exploring Magnets. Resma lives in a coastal town of Kerala and it's very fond of writing short stories. Her grandmother loves listening to her story, so Resma was writing a new story to share with her grandmother on her 60th birthday. The story was based on a ship carrying spices from Kerala from trade in the olden days. Resma was aware that in those days the sailors used uh, stars to find direction at night. But in her story, a situation arose wherein a sailor got caught in a storm with an overcast sky and stars were not visible. Resma could not take her story forward as she could not think of a way for sailors to find direction. She searched for information on the internet and her school library. She learned that the travelers used a device known as a magnetic compass for finding direction. Resma had seen pencil box and purse which had magnet to keep them closed. A writing board in her schools also had a duster with a magnet. But she had never looked at those carefully. She now became curious to learn more about magnet and magnetic compass. And now we are also excited known for magnetic compass. The magnets used by sailor in the olden days were based on naturally occurring magnets known as lodestone, which were discovered in ancient times. Later on people found out that magnet could also be made from pieces of iron. Nowadays, we have magnet made of different materials. The magnet that you find in your school laboratory and those used in pencil box, stickers, toys are all artificially magnets. The magnets can be of various shapes, some of which are shows now. Bar magnet, U-shaped magnet, ring shaped magnet. These types of magnets, magnet and non-magnetic materials. So let's we started activity 4.1. Collect a new object made of different materials and also a magnet. Predict which of the object will stick to the magnet. Write your prediction in table 4.1. Now hold a magnet in your hand and bring it near the object one by one. Observe which of the objects stick to the magnet and record your observation in table 4.1, and this table you fulfill. Was your prediction correct for all subjects? Which material stuck to the magnet? What conclusion can you draw? Through this activity, we found out that some of the objects were attracted to the magnet and stuck to it, while others were not. The materials which are attracted towards a magnet are called magnetic materials. The metal iron is a magnetic material. Nickel and cobalt are other metals that are also magnetic. Some of their combination with other metals are also attracted towards magnet. The materials which are not attracted towards a magnet are called non-magnetic materials. Which materials listed in table 4.1 were found to be non-magnetic? Poles of magnet. So let's we started activity 4.2. Separate some iron, feeling very small pieces of iron on a sheet of paper. Place a bar magnet over them, tap the paper and observe carefully what happens to the iron fillings. Do you observe anything special about the way they stick to the magnet? Do the iron filings stick all over the magnet informally, or do the iron filings stick more at some place? We find the maximum iron findings stick near the end of the bar magnet as shown in figure 4.4, while a very few iron filings stick at the remaining part of the magnet. And now we will find a question. If we repeat this activity with the magnet of other shape, do we get the same result? Of course. These ends of the magnet are called the two poles of the magnet, the north pole and the south pole. Most of the iron filling stick to the poles of magnet of any shape. It is not possible to obtain a magnet with a single pole if a magnet is broken into similar pieces. North and south pole always exist in pair even in the smallest pieces of magnet. A single north pole or a south pole cannot exist. Finding direction. So, activity 4.3. Let's experiment. Suspend a bar magnet with a thread tied to the middle of the magnet as so in figure 4.5. You may need to adjust the position of the steering till the magnet is balanced horizontally. Now rotate the magnet gently in the horizontal direction and let it come to rest. Mark the position corresponding. Mark the position corresponding to the ends of the magnet on the ground or on a pieces of paper stuck to the ground. Join these 2 points on the ground with a line. This line indicates the direction along which the magnet comes to rest. Now again rotate the magnet by giving a gentle push at it once and wait till it comes to rest. Does the magnet rest along the same line? What direction does this line indicate along which the magnet rests? How can we find it out? If we have noticed the direction where the sun rises or sets, we have an ex- approximate ideas of whether east or east. Hence, we can locate the direction along which the magnet rests. A freely suspended magnet comes to rest along the north south direction. The end of the magnet that points towards north direction is called the north seeking pole or the north pole of the magnet. The other end that point towards the south direction is called the south seeking poles or the south pole of the magnet. A freely suspended magnet rests along the north south direction because our earth itself behaves like a Gantt magnet. Repeat this activity with a small iron bar in place of the bar magnet. What do you observe? Does it always rest along north south direction? It does not. It can rest along any direction. This implies that only magnet rest only north south direction. This activity provides us with a way to test whether a piece of metal is a magnet or not. The properly the properties of a freely suspended magnet to always rest along the north south direction is used to find direction. Based on this, a small device called a magnetic compass was developed in olden days of finding direction. It has magnet in the shape of the needle which can rotate freely. The needle of the magnetic compass indicates the north south direction. The compass is kept at the place where we wish to know the direction. After some time, the needle comes to rest in the north south direction. The compass box is then gently rotated until the north and south marked on the dial are aligned with the needle. Now all direction at the place are as indicate on the dial. A magnetic compass is usually a small circular box with a transparent cover on it, as shown in figure 4.6. The magnetic in the shape of a needle is mounted on a pin standing on the bottom of the box. This needle is balanced on the pin such a manner that it can move around this point easily. That is, it can rotate freely. The end of the needle, which recessed in the north direction, is usually painted red. Below the needle, there is a dial with direction marked on it. Who can mark our own magnet compass? So let's start it. Activity 4.4. Collect a few materials like a cork pieces, iron swelling, needles, a permanent bar magnet, a glass bowl, and water. Place the iron swing needles on the wooden table. Then keep any one pole of magnet at one end of the needle. Move the magnet or the needle along its length as shown in figure 4.7. When it reaches to other end of the needle, lift it up. Bring the same pole of the magnet you started with to the same end of the swing needle from which you began, and repeat the previous step. Repeat this process at least 30 to 40 times. Bring some iron fillings or steel pins near the needle. If the pins or iron fillings get attracted to the needle, then then that means that the needle has become a magnet. Pass this needle through the cork horizontally. Float the cork in glass blow filled with water such that the needle always remain above the level of the water as shown in figure 4.7. When the needle comes to rest, your magnetic compass is ready for use. Note the direction in which either side of the needle points. Rotate the cork gently and wait till it stops rotating. Repeat this a few more times. Do the ends of the needles always point in the same direction? And do you know, much before the whispered use of the modern magnetic compass, a device similar to compass needle made by you was used by Indian for navigation at sea. It consisted of a magnetized fish-shaped iron pieces kept in a vessel of oil. It was called Matsya Yantra or Machyantra. What happens when we bring two magnetic closer to each other? Attraction and repulsion between magnet. Activity 4.5. Take a pair of bar magnet on which north and south poles have been marked. Mark the two bar magnets as A and B. Place the longer side of magnet A cover 5 to 6 round shaped pencil as shown in figure 4.8. Now bring one end of magnet B near the end of magnet A placed on the pencil. Make sure that the two magnets do not touch each other. Observe what happens. Next, bring the other end of magnet B near the same end of magnet. Does the magnet A on the pencils begin to move? Does it always move in direction of the approaching magnet? What does the observation suggest? You will see that unlike poles of two magnets, that is, the north pole of the magnet and the south pole of another magnet attract each other. They like poles, that is, either the north poles or The south poles of both magnets repel each other. It means same direction repel. Repeat the activity by using as an iron bar in place of one of the magnet. What do you observe this time? You will find that both the ends of the iron bar will be attraction both the north and south pole of the magnet. From this activity we find that a magnet can be identified by its properties of repulsion. Let's uh, experiment activity 4.6. Take a magnet, compass and bar magnet. Place the magnetic compass over a horizontally surface and wait for its needle to come to rest. Now slowly bring north pole of the bar magnet close to the north pole of the compass needle as shown in figure 4.9. Observe the compass needle carefully. What do you observe? Does the needle deflect? If yes, in which direction? Now repeat the above step with the south pole of the bar magnet. Do you observe any difference this time? When the north pole of a magnet is uh, brought closer to the north pole of the compass needle, it moves away as shown in figure 4.9. When the south pole of the magnet is brought closer to the north pole of the compass needle, it moves closer. Suppose we place a piece of wood between the compass needle and the magnet. Will this affect the deflection of the compass needle? Activity 4.7. Let's say investigation. Repeat the first or second part of activity 4.6 without disturbing the bar magnet and magnetic compass. Place a piece of wood between them perpendicular to the table as shown in figure 4.10. Observe the compass needle carefully. Is there any effect on the deflection of compass needle due to the piece of wood? Record your observation in table 4.2. Repeat the process by replacing the pieces of wood by a cardboard sheet, thin plastic sheet, and thin glass sheet. And this table you fulfill. You should observe that there is no appreciable change in the deflection of the needle when a sheet of any of the above material is placed between the magnet and the compass needle. So we can conclude that the magnetic effect can act through non-magnetic materials. Fun with magnets. After learning about magnet, Resma was very excited and decided to set up some fun activities using magnetic at her school fair. You may try making these yourself and may also think of some more fun ideas. Can you make a garland? Magnet can move some object without touching them. It's that not amazing. Magnetic garland, yes, of course we will make. We can take the seed poles out of the maze by moving a magnetic below the cardboard tray. Can we pick out a steel paper clip fallen in water using a magnet without making your fingers or the magnetic weight? Yes, we will try. Will the two cars speed towards each other or run away from each other with brought closer, right? Because this is a different poles were attraction and same poles are repulsion. In some magnets the north and south poles are marked as N and S. In some other magnet the north pole is indicated by white dots and Why don't sometimes the north pole of a magnetic is painted red and south pole is painted blue? So we will find out difference in north pole and south pole. How to keep the magnet safe, store me properly, keep me in pairs with unlike poles on the same side, keep a piece of wood in between, place two pieces of soft iron across the end, don't heat me or drop me or harm me, do not keep me near mobile phones or remote controls. So this lesson we will complete it. So thank you so